Hey everyone, this is Bennett Townsend, and I'm going to be going over the protocol we were assigned this week, which was SSH as well as OpenSSH. So let's start off with the protocol. SSH actually stands for Secure Shell, and what it is a cryptographic network protocol that allows secure communication between network devices, and it actually communicates over port 22. So SSH uses a client server architecture, and it provides a strong encryption and authentication mechanisms. And one of the most widely used implementations of SSH, which we will be going over a little further later, is OpenSSH. And OpenSSH is actually a free and open source software suite used to securely connect remote machines through the SSH protocol. So SSH is a network protocol that allows users to securely access and manage remote systems over an unsecured network. So SSH is designed to be secure, reliable, and efficient, and is widely used by many system administrators and developers to manage remote systems within the environment. So it uses a client server. The protocol SSH uses a client server model where the SSH client connects to the SSH server to establish a secure communication channel. The SSH protocol provides strong encryption, integrity, and authentication mechanisms to ensure that the communication channel is secure. So the purpose of SSH was to replace unsecure terminal emulations such as Telnet or RSH, which were used previously and were actually both well known for attacks. So both protocols were vulnerable to attacks. SSH utilizes a terminal session to connect to the remote host by using command SSH and then the host, which is user at server.example.com, just as an example command. And an SSH connection will be attempted to the server, which for this example could be server.example.com, by the user that was predefined in the host command uh, previously. And then the host key will be exchanged once connected, and once the connection is confirmed, the key will be stored on the local system, which will be used for further connections. So SSH is a widely used tool found in just about all data centers and is included by default in Unix, Linux, and Mac servers. It's primarily used for managing routers, server hardware, virtualization platforms, operating systems, and file transfer applications, all while ensuring a secure connection. So connecting to these systems allows users to connect and make changes, maybe perform uploads and exit processes either through the terminal or using tools such as OpenSSH. So the keys associated with SSH can be configured to further automate access to servers and can be used in scripts, backup systems, and configuration management tools. Now, SSH keys provide single sign-on or SSO to enable users to move between their accounts without need to re-enter their credentials each time. So now let's kind of move on to OpenSSH. And as I mentioned before, OpenSSH is a free and open source implementation of the SSH protocol suite. OpenSSH provides a set of client and server tools that allow users to securely connect to a remote system remote systems and manage them. So OpenSSH includes the SSH command line tool, which is used to initiate any SSH connections, and the SSHD daemon, which runs on the remote system and provides the SSH server functionality. So OpenSSH is included in most Linux distributions and can be easily installed using the package manager. So to install OpenSSH on any Ubuntu or Debian machine, you can use the following commands: sudo apt-get install OpenSSH-server. And what this will do will install the OpenSSH server, and it will enable it to start automatically on boot. Once OpenSSH is installed, you can use the SSH command to connect to remote systems securely. There are many features within OpenSSH config file, which is /etc/ssh/sshd_config, that can help further configure SSH, such as specific communication settings or authentication methods. So, doing research, I was also able to find some hardening recommendations. And let's go over. I was able to find 4. There were a few more, but I just included 4 for this presentation. So the first one is passwordless authentication. So passwords can be guessed, and because a password is required to connect with OpenSSH, this means that an attacker can either guess or brute force through the authentication process. So if there is no password to guess, this makes it more difficult to bypass the authentication process and connect to other servers or devices. So an SSH key pair must be generated first before passwordless authentication can be enabled. And this pair consists of a public key and a private key. And once the private key is generated, it will live on the host system, while when the public key is generated, it will be copied to the remote server, so whatever you're connecting to. Now, the public key being present on the remote server will allow the server to be accessed from the host server without a password, and only the host server. But you must also disable the password authentication setting in the SSH configuration file by opening the config file with any text editor, such as nano. And the config file again is /nano/ssh/sshhd_config. You'll then scroll down to password authentication and change yes to no, save the file, and restart the OpenSSH server. The next hardening recommendation would be disable empty password requests. So when accounts are created, sometimes the password may have been overlooked. So it's important to ensure that everyone who's connecting to via SSH is required some type of authentication, whether it read password or use an SSH key authentication. So to avoid any users from connecting via SSH without a password, you must change the permit empty passwords line in the SSH config file. I'm not going to state it again. I've stated it a couple times, but the same config file we've used previously, and scroll down to permit empty passwords and change to no, and then again save the file and restart the server. We can also disable root logins. So using an account that has root access is really never a good idea to use on any application, as if the application is compromised, that account can then be used to access all other resources. So it's advised to disable the root logins and use a non-root account. Now, this can be done again by opening the same configuration file for SSH and changing the permit root login to no. And lastly, the hardening recommendation that I found was changing SSH protocol, I'm sorry, changing to SSH protocol 2. So by default, SSH uses protocol 1, but protocol 2 is preferred as it is a newer and more secure version of SSH. So to switch the protocol, you must add a line protocol 2 to the configuration file that I've stated previously, and you'll have to then restart the server. And then to confirm you're on the right protocol, you can run the command ssh-1 user at remote-IP, or whatever IP you're connecting to. And if you've changed the protocol successfully, you will receive um, an error of SSH protocol v.1 is no longer supported. And again, you can further confirm you're using protocol 2 by running the command ssh-2 user at remote-whatever IP you're connecting to, and you'll be prompted for a password or connected successfully. So that is the end of my presentation for SSH and OpenSSH. Here are all the references that I've used for this presentation and research. And as always, I look forward to hearing what others have to say about what I found and looking at what others were able to find on the assigned protocols this week.